design scope gaps, constructability issues and water intrusion risks. Through the process, over 50 connections were redesigned in the model prior to panel fabrication on the same project, which was submitted for and awarded both the 2010 Tekla North America and Global Award for BIM collaboration. A second project, the Sutter Alder Bates Summit Medical Centre. This was submitted for and awarded the 2011 Tekla North America Award for BIM collaboration. So Nathan's very passionate about transforming the construction industry through technology-driven innovations. So I think this should be a really interesting talk, actually. So I'll just pass it over to Nathan. Thanks.
Great, thank you. No, just listening to some of the roundtable comments, I think we're definitely struggling with a lot of the. I'm sorry, is it okay? Okay. With the same issues as far as training and aptitude and validating the cost of BIM and some of the 5D issues as well. So unfortunately, I don't think 15 minutes will be enough time to go through everything, but I'll talk fast and get through what I can. So quick background on Dpr Construction, for those who don't know, we started about 23 years ago in 1990, have grown to over $2 billion, mainly in the U.S. We have 17 offices within the U.S., 1,300 salaried staff, and we are a self-perform. We self-perform our own concrete and drywall work, as well as some other miscellaneous scopes, with 1,400 craft employees. Within the last few years, we've started a Dpr consulting group, with some folks stationed in South Korea as well as Colombia, and looking for other opportunities to help owners and other international contractors to implement lean BIM. The core markets that we focus on at Dpr, generally fairly complex, highly technical construction, advanced technology, corporate green office, higher education, healthcare, hospital work, as well as life sciences and biopharmaceuticals. Our core values, you can see here, integrity, enjoyment, uniqueness, and ever forward. But really what we're going to focus on today is our culture of ever forward and this belief in self-initiated change and always looking for new opportunities, new advancements to really transform our industry and transform the world. A quick background on myself, I think it's already been given, but my background comes from a civil engineering graduate degree. Started with Dpr Construction in 2009, have worked on both of the Sutter Health hospitals, Castro Valley and Alta Bates, which were both IPD projects. And like it was said, I'm now part of our corporate innovation team, helping other projects learn from successes of these projects and others, and continuing to share and push the industry. It was mentioned about the Castro Valley project. A lot of the examples throughout this presentation come from the Castro Valley project. There are 2 different webinars if folks are interested in learning more about how Dpr leveraged BIM during construction. They're on Tekla's website under the webinars tab for contractors. You can see one for both the Alta Bates project as well as the Sutter Castro Valley. So before I go into this steel example, just some quick key concepts and definitions to go through. The first one, we talked about lean processes and really what is lean thinking. And we use a quote from Taichi Ono, creator of Toyota production system, that we're really looking for the right product at the right time at the right quantity. And at the end of the day, it's really about reducing waste, really taking a step back, looking at our workflow, looking at our process, not thinking what the traditional way was, but thinking outside the box on how we can drive efficiency through this new BIM workflow moving into construction. And then it may seem like a silly question, but we always ask ourselves, what exactly is BIM? And I always have to go back to our U.S. national BIM standard, and I always like to highlight that BIM is a shared knowledge resource for information about a facility forming a reliable basis of decision. So the comment on do we trust our model is a huge issue that we deal with, and it's a lot of work to make sure that we do keep our model up to date and that we trust our model. So we'll be talking about this as well. We talked about giving everybody access to the model, being a shared resource, and I like to think of BIM as a communication hub, where we're really driving to maintain our schedules, maintain our estimates, maintain all of our submittal and construction level scopes of work tied to the model. As we go out into the field, any requests for information are also tied back to the model. And then when things do change in the field and we have as-built conditions, that we're actually going through that process of updating the model back to what was built in the field, that when we hand that over to the owner after the project, he's confident and trusts this model as an accurate representation of what he built, sorry. And then the last key concept here is the concept of model what you build and build what you model. I think when BIM first started, we really thought of it as a design tool to coordinate the design, flatten it, and then build it. And we're really changing that mindset now, where we want to bring that field knowledge into the model, bring their experience to build the model as if we were building it in the field, and then take that information and effectively communicate it out to the field so that they're building it the same way that we built it in the model. So the example I'm going to give today is a steel detailing workflow. On both these projects, we work closely with our steel fabricator and detailer. They use it was Herrick Steel and Candraft out of Canada that did the detailing for this work. And I'm just going to quickly run through kind of the typical traditional path within a BIM world of how we design and fabricate our steel for construction. So our 3D designer, our design engineer will create his 3D model, most likely in Revit, and that will produce 2D design engineering drawings. And so traditionally our detailer will take those drawings and he will manually create a 3D model, most likely in Tekla, with more information, but based off of those 2D drawings. Then he creates his own 2D shop drawings, of which the design engineer comes and marks up by hand on the piece of paper. Hopefully we don't have any iterations or revise and resubmit, but if we do that, we go through that process, and then those drawings go to the fabricator to get fabricated. So quite a bit of steps in here, and so we're really going to try and think outside the box and how we can reduce the amount of steps in this process. The first question that we ask ourselves are, if this Revit model is going to 2D flattened drawings, and then the 2D flattened drawings are then getting created into another 3D model, how do we even know that the design engineer's Revit model is even aligned or matching the detailer's construction model? Because for us, we spend a lot of time coordinating our MEP trays around the designer's model because we don't yet have construction model available. And so we actually did this exercise. This was actually from the Alta Bates project, and overlaid, you can see the orange and green beams are coming out of Tekla from the steel detailer, and the design engineer model is in gray. And you can see the differences between some of these intermediate beams. Now they still meet the design intent, they're still correct as per the 2D drawings, but the actual geometric configuration is different. And so where we've coordinated and slightly shifted beams due to plumbing penetration, so on and so forth, we're basically coordinating off of false information. So we really want to make sure that these two models are actually aligned. We also run into issues just in the fact that there's more detail and more connections and more shapes within our construction model, the Tekla construction model. And so this often results in clashes that we would not have normally seen with MEP. You can see here the difference between where the simple design stick model does not show a clash between this plumbing pipe, but once you bring in that connection and that gusset plate, you see that there's a connection. So it's really important for us to make sure we're always going off the latest information with the greatest amount of detail that we're actually going to use for construction. So how can we do this differently? Let's think about a new workflow. So instead of creating these 2D drawings directly from the 3D model, which really seems wasteful and an unnecessary step, we can just give that Revit model as an ISC export to the detailer, and they can bring that into Tekla. And Tekla does have a tool now where you can convert directly from Revit IFC or really any IFC to Tekla. I would say that for concrete and for other odd shapes, it's not quite there yet, but when it comes to steel, a steel stick model, it's actually really quite good at taking the designer's information, directly converting it to Tekla for you, that we're not spending that extra time and effort to recreate the model so that we can add our connections. It can start right at the point of adding connections. It also allows, by bringing the detailer and bringing that detail model on earlier, allows us to do more constructability review and make better constructability decisions when clashes are encountered. Here's one situation where there was a fire line penetrating through a steel beam, and rather than routing it around it, it made more sense to actually cut a penetration through that beam. And it's much more cost effective for the fabricator to do that in their shop than it is out in the field. So we were able to coordinate the location of that, drill that hole in the shop rather than in the field. And because everything was coordinated in the model and actually built per the model, we're able to bring that through without any field issues. The same can go for rebar. We have much more complex jobs now where really the level of complexity and the level of unknown drives the amount of 3D modeling that we want to do. And on some of these seismically compliant healthcare projects in California, have a lot of rebar and a lot of steel. And what we can do now in Tekla is take the fabricator's steel model and give that to the rebar contractors so that when they do their rebar detailing, they can see exactly where the holes will be drilled in the steel plates to them to thread their bar through, make sure that it's constructible and comes out on site without any issues. The next thing we can do to save time and not try and get away from paper is actually bring that submittal, bring that shop drawing review into the model. Herrick Steel, in conjunction with CanDraft, has developed their own API within Tekla that will actually allow you to complete your review and even save time completing the review by clicking one button and reviewing all the connections that are the same connection as the one that you're reviewing. But from the experience of our structural engineers, they really like this workflow. It's much more efficient for them, and I think everybody's happier at the end of the day. And we don't have to deal with paper drawings. So in final, the best workflow, if we're not going to do paper and we're going to directly transfer the designer's model to the fabricator's model, and then review that within their model, now all we really have to do is for the shop drawings that do still need paper, that are going to be hand welded, goes to paper. And anything that can be done by directed CNC goes direct to our CNC machine for cutting, drilling, and welding. So you can see from the original workflow, this one is a much more efficient process. And it's really going to get us to the point where BIM is finally saving us money rather than costing us money because we're looking at our workflows and really driving more efficiencies through a model basis. And so to finish up here, dealing with the challenge and dealing with training and everything that you guys are mentioning, too often we focus just on the tool. We focus just on BIM, and we don't focus on the other components, which are really the people involved in it and the full buy-in of the project team, and also that process and developing a new process that aligns well with this tool. And so in this case, our tool is BIM. The people that we need buy-in from are first and foremost owner. The owner is key. I mean, there's the mention of finding that first project to do BIM on, and it's really not going to happen unless you find an owner that is frustrated with the current system, understands that the system is broken, and wants to try something new, that's willing to commit and risk trying something new. So it really starts with the owner, but then it can't be successful if you don't have buy-in from the designers, the contractor, as well as all the subcontractors that are going to be involved in this process. And the only way to really get involved and keep them tied in is through a good contract, whether it's integrated project delivery or not. The contract language should spell out exactly what we're trying to do and the efficiencies we're trying to achieve. And we should have a pretty detailed BIM execution plan and know exactly who's doing what they're naming their models, how they're going to be organized. It's got to be very prescriptive if it's going to be successful. And then we have to follow with training because this is new to a lot of folks, and there's going to be an inherent learning curve and resistance to change. And we have to be optimistic about it and really put our hand out and help folks in training to make sure that this process is successful. And so with that, hopefully I kept that fairly short, and maybe there's some time for some questions.
Yeah, no, that was just about perfect, Nathan. If anyone's got any questions for Nathan while we've still got him on.
Yeah, and if you could really speak up, because I can barely hear you guys on the
All right,
line.
okay.
You have to relay the questions.
Yeah, I'll relay the questions. So, is anyone?
Right, thank you.
So you talk in the presentations in one point about bin costing and
Yeah.
then saving. Is that in terms of number of contracts or a period of time? When did it go from being a cost to actually being a save?
Okay, so there was a comment about BIM costing you money, and at one point that tipped to BIM saving you money. So was that a time span thing, or was that number of contracts? What was the tipping point for that to you guys?
From a cost standpoint, really the driving factor is going to be the complexity of the project. In general, the most successful BIM projects that we have had have been in either very heavy MEP processing and within our life sciences projects and biopharmaceutical facilities, or in healthcare, and especially in hospitals, because not only do you have a lot of mechanical, electrical, plumbing equipment, but you also have to fit it within a very tight space. And I think historically you can look at the data of the schedule overruns, the cost overruns of a complex hospital, and it becomes much easier to justify the investment, is what I like to call it, up front in doing this BIM workflow and the coordination. And so, by volume, I believe we have a stat that by volume, 90% of DPR's projects have some sort of component of BIM, but the level of BIM that we go to is very much dependent on the complexity of the project.
Good answer. I've got a question for you myself. You mentioned, you talked about using Tekla before and working with IFCs provided by others. I mean, I'm not sure how your processes are set up, but if you receive a model from someone else, what is the process you go through to make sure that the information in the IFC model is valid? Is there a sort of a validation process that you run through generally, or is it? Do you trust the information that you get in IFC? Is what I'm trying to ask, I suppose.
Yeah, so within the contract we had, fortunately we had language within our contract that says that the model is the single source of truth, or when there is a discrepancy between a 2D drawing and a 3D model, the 3D model will override the 2D drawing, which is a very rare thing.
Yeah.
So first and foremost, having the contract is really important, because there will be situations where you'll run into issues, and if it becomes a legal claim because someone was trusting a 3D model, then we can get into trouble pretty quickly. But I do know that there are still some issues with IFC and geometry. We don't only do IFC. IFC works well when we're within Tekla, but from a coordination standpoint, when it relates to the interior coordination of MEP trays, we do still use the Navisworks workflow with DWG models, which are more reliable when it comes to the geometry, but we just don't get as much information from them.
Yeah, sure. Are there any more questions?
One quick one. How early do DPR get involved in the design process?
Yeah, so Nathan, how early do DPR usually get involved in the design process?
Not early enough, and really it is very early in the design process on these successful jobs. On these jobs here, we broke ground on the Castro Valley project in 2009. I think we were doing pre-construction with Sutter for over 3 years. So usually between 2 and 3 years before construction starts on these larger hospital projects, we're already on board and running coordination, and we have the majority of our mechanical, electrical, plumbing trades are all on board, and in most cases we also have exterior skin and structural steel on board as well.
One final one from me, if no one else has got any questions. So you get involved earlier on in the process. How do you deal with BIM and the knowledge of the supply chain? So let's say, so as a contractor working with others, how do you benefit from your supply chain being knowledgeable? If they're not, do you take any steps to sort of educate them, or perhaps have workshops or anything along those lines?
As far as the subcontractors that we're dealing with?
Yeah.
So it definitely depends on the subcontractor. I think within the mechanical and electrical plumbing trades, they are oftentimes more savvy or have a higher level of BIM, and they have completely ingrained the shop fabrication process through the model, and they're almost teaching us more than we're teaching them. But we do encounter folks where we realize things along the way. I mean, this story about the steel detailing, I mean, that's a real life story. I mean, that is their process, the conventional process, and through discussing, through transparency, through collaboration, we learned about these inefficiencies and had discussions about how to improve on those efficiencies. And we have seen, you know, different changes in the steel workflow and the detailing workflow because of these experiences. So, I mean, I can't say that we know everything, but we learn along the way, and we really focus on transparency and communication.
I think, is there any more before we... I think that's it, Nathan. That's been extremely enlightening for me anyway. It's very helpful. So I think we'll probably move on from that.
Great, and yeah, my email's up there. If anyone has any follow-up questions, you know, feel free to shoot me an email, and we can get in touch.